what a REST API is, how it works behind the scenes, and how developers use it in real applications. If you've ever used a mobile app, a website login, a weather service, or an online payment, you've already depended on REST APIs. In this tutorial, we'll break the concept down step by step with practical examples, real request flows, and code usage, so even beginners can follow along confidently. Let's start with the foundation. AP stands for Application Programming Interface. In simple terms, an AP is a defined way for two software systems to talk to each other. Instead of directly accessing another system's database or logic, applications send structured requests to an AP and receive structured responses. This keeps systems secure, modular, and scalable. Think of an AP as a communication bridge between a client and a server. The client could be a browser, a mobile app, or another service. The server holds data and business logic. The AP defines how requests must be made, what format they should follow, and what responses will be returned. This structured contract allows different systems to work together reliably. Now let's focus on REST API specifically. REST is the most widely used architectural style for building web APIs today. REST APIs communicate using standard web technology, mainly HTTP, which makes them simple, fast, and universally supported. Because REST follows consistent rules, developers can quickly understand and integrate new APIs. REST stands for Representational State Transfer. While the name sounds complex, the idea is practical. REST defines how resources are represented and transferred between systems. It encourages predictable URLs, standard methods, and structured responses. It is not tied to any programming language, it's purely an architectural pattern. In REST design, everything is treated as a resource. A resource is any piece of data or entity your system manages, such as users, products, invoices, devices, or messages. Each resource type is grouped logically and exposed through endpoints. This resource-based structure makes APIs intuitive and easy to navigate. Each resource is accessed through a unique URL called an endpoint. For example, slash users might return all users while slash users slash 5 returns a specific user. Endpoints are designed to be readable and meaningful. When designed correctly, you can often understand what an endpoint does just by reading the URL. A key REST principle is statelessness. This means the server does not remember previous requests. Every request must include all necessary information, authentication tokens, parameters, and identifiers. Stateless design improves reliability and scalability because each request can be handled independently. REST APIs rely on standard HTTP methods to express intent. These methods are like action verbs. Instead of writing custom action names in URLs, REST uses get, post, put, and delete to clearly define what should happen to a resource. This standardization makes APIs predictable and easier to use. Get is used to retrieve data from the server. It never changes the data, it only reads it. For example, sending a GET request to a user's endpoint may return a list of users. GET requests are safe, catchable, and very common. Most AP traffic consists of GET operations. POST is used to create new resources. The client sends data in the request body, usually in JSON format, and the server creates a new record. For example, posting user details to a user's endpoint creates a new user. Post changes server state and typically returns a created status code. Put is used to update an existing resource. You send updated data to a specific resource URL. For example, sending a put request to user slash 5 updates that user's information. Put is idempotent, meaning repeating the same request produces the same result. Delete removes a resource. When you send a delete request to a resource endpoint, the server deletes that record if permissions allow it. Proper APIs return confirmation status codes so clients know whether deletion succeeded. Let's look at a real example. If you open a public test AP endpoint in your browser, the server instantly returns structured JSON data. This demonstrates how REST APIs are accessible over normal web URLs and respond instantly to valid requests. Let's look at a real example. If you open a public test AP endpoint in your browser, the server instantly returns structured JSON data. This demonstrates how REST APIs are accessible over normal web URLs and respond instantly to valid requests. Most REST APIs return responses in JSON format. JSON is lightweight, structured, and easy to parse in nearly every programming language. It represents data as key value pairs and arrays, making it ideal for transmitting structured information between systems. Every AP response includes an HTTP status code. These codes quickly communicate the result. 200 means success, 201 means created, 404 means not found, 500 indicates a server error. Understanding status codes helps you debug and handle errors correctly. Developers often test APIs using tools like Postman before writing code. These tools let you choose the HTTP method, enter the endpoint, attach headers, send request bodies, and inspect responses visually. This speeds up development and troubleshooting. In JavaScript, REST APIs are commonly called using the fetch function. You send the request, convert the response to JSON, and then use the data inside your application logic. This is how websites dynamically load data without reloading pages. In C# and .NET applications, REST APIs are typically accessed using HTTP client. It allows you to send requests asynchronously and process structured responses. This is widely used in backend services, desktop apps, and cloud integrations. Once you understand REST APIs, you unlock the ability to connect systems, integrate services, and build scalable applications. REST is one of the core building blocks of modern software architecture, and mastering it is essential for any developer working with web or cloud technologies.